Well, here's a few news stories. This one, I think, is the main one. There was an announcement last night that we could expect this, and now it has happened. President Biden has put sanctions on Russia to punish them for the cyberattack, including rigging the last election, which they meddled in the last election and the one before it. And they put bounties on our soldiers in, I think, Afghanistan to get them killed. And they did the SolarWinds attack that hacked into everything, where they're almost certainly still in control of an enormous number of machines here. And it will take years to clean out all the backdoors they put in, if indeed we ever get them out. It's extremely serious. And they could do all this with complete impunity while Trump was in there, because Trump always believed anything Putin said and never said a word against Russia for some reason, which has not yet completely been explained. But Biden is not that way. And so this is pretty serious. They're throwing out 10 people in America. It targets 30 Russian entities and individuals. They're expelling 10 personnel from the diplomatic mission and targeting 6 Russian tech firms. So it's possible that this will catch Putin's attention. And we're definitely entering a time of much more hostile relations with Russia. So anyway, and largely over cyber attacks. Something I think is richly deserved and long overdue. And apparently we're going to be in a more hostile relationship with China. Trump was very hostile to China, and Biden seems to be continuing in the same way. Of course, China is stepping up their offenses, like crushing people in Hong Kong and engaging in genocide and concentration camps and forced rape and everything else, appalling stuff to their Uyghurs. So they really are an extremely disturbing regime. And however, it's not entirely clear that the United States can do anything much that will affect China. But anyway, they are talking about a more hostile attitude towards China, although I think nobody on either side wants a war. So it's not quite clear what they're going to do. I guess more trade sanctions or something like that. But anyway, at least they're talking tough for starting, and they probably will follow with some kind of further efforts to try to put some pressure on China, which is also guilty of an incredible amount of cyber attacks against America and has been doing it for a long time. And we really haven't seemed to find anything significant to do to deter it. This is the problem. The United States is pretty much just like a dumb elephant getting attacked by these other countries without any way to strike back, so far. Poison Apple is interesting. Mac malware exists, and this is a persistence tool to put on a Mac that will automatically reinstall a backdoor and let you remote control the Mac. So it's a sort of a little piece of a cyber attack that you could use in a penetration test or something. And of course, these things are often re-implemented into real malware that infects people. So Gavin Newsom wants to open all the schools in the fall, which makes total sense to me. I was surprised when I got my fall schedule about a week ago, the first draft of it for approval, and it said all my classes are remote. And I said, well, I'm happy to teach those classes, but I'd like to teach them face-to-face. And they said, well, we're going to open the City College in the spring of 2021, spring of 2022, I guess. But in the fall, we're only going to do selected classes that request to be face-to-face. And I said, well, I'm requesting to be face-to-face. Now, of course, when I do face-to-face, I continue to do what I'm doing now. I put it on Zoom, or I guess I'll probably use Twitch, so that anybody can connect remotely if they want to. And so the end result is only a few students actually come face-to-face to the class. But I'd like to be there because I got the vaccine. I'm not afraid of the COVID anymore. And also, I think there are students, especially in my 128 class, that just can't get anything done because their technology at home is too weak. So it'll be much better to have some availability of lab hours and some ability to help people face-to-face. So anyway, nothing has been officially decided by the college yet, but I expect I'll have all my classes face-to-face again next semester for my classes, but apparently not for very many others. Apparently a lot of teachers still think like they have to hide in the fall. I don't know why. I don't know what they're waiting for. The vaccine is out, and I don't think anything better is going to appear. But anyway, the Mars lander. Not the new one, but I think an older one. The Mars lander is in crisis because there hasn't been as much wind as expected, so the dust has just piled up on the solar panels until it's hardly getting any power. So it's gone into a hibernation mode, which it can do for some period of time, and then hopefully the wind will come blow the dust away before it runs out of residual battery power, and then they can activate it again. We'll see. All right, and I got a couple of minutes left. Oh yes, I remember what I wanted to do. I wanted to mention all these upcoming events. There's a lot of upcoming events, and all these are worth extra credit and highly recommended. Tara Wheeler is giving a talk in Britain, so it is at 6 a.m. our time tomorrow morning. I'll probably tune in for people who want to get up early. It should be very good, about cyber war crimes and how they will affect individuals. Then there's two good ones on Saturday. SOC 2 audit preparation, which I think is very interesting, and Kubernetes security. These are a very good group. Mac Miami and Pacific Hackers, I highly recommend attending these, tuning in. They're all free and online. And then on Tuesday, there's another Tech Talk. So these are all good events, worth extra credit if you need any credit. And I recommend them for their educational value. And got about half a minute left. I think there's no point to stand on ceremony. So here we are. We're at 129S. And midterm grades are out, and there's really not a whole lot more left to the semester. For some reason, the midterm is more than halfway through the semester. As you see, there's only about 4 or 5 more lectures. So we're up to the application logic chapter. And this one here, I don't have any cahoots because this is really not general principles. This is just a list of case histories of vulnerabilities found by the textbook authors, just to serve as sort of an example of logic flaws. And this shows not everything is technical. There are just things that just haven't been thought through very well, which is extremely common. One simple example I heard of years ago, I had one of these things. There was Windows had thumbprint authentication for like Windows XP boxes 10 years ago. And Microsoft and Apple funded a company to make a USB thumbprint reader that would plug in the USB port, and what it would do is it would read your thumbprint and then it would type in your password. So what that meant is the software had to have access to your plain text password, so it totally subverted the security model of Windows and Mac that don't store your plain text password anywhere. And this mistake has been made several times, so it's a kind of logic flaw. These events count toward extra credit in any of my classes. Yes, any of my classes. But only, you get, each one is worth 10 points typically, and you can put 10 points in any class you like. Good? But you only get the points once. I had a student who was a lawyer actually threatened to sue me and the college because he took like 3 of my classes, and he wanted every extra event to count in every class, multiplying the points by 3, and claimed that I had promised that. So it reminds me to make clear I'm not promising that. Yeah, but anyway, I highly recommend going to these events. There's so many good tech events, and they're perfectly fine, just as good as this class or anything. Good things to learn. Anyway, so there's no particular signature. It's not a SQL injection. It's not something you'd find with a vulnerability scanner because it's not a known defect in one control where this input has that unexpected output. It's just that you didn't really think through the steps of what you're doing. So here's one. So you log into the website. When you turn on Remember Me, it puts a cookie on your machine to remember who you are, which is fine. But instead of just having the cookie be a meaningless random number, which would be the safest thing to do, they put in an encrypted string that's got your name and so on. So that's fine. The problem is they also saved your screen name in an encrypted form as another value, and they used the same encryption. So they used the same encryption procedure for a high-value secret thing and for a public thing, which you know. So I think you can see what's coming. Since the user can control the screen name, and the app decrypts that cookie, so it stores your cookie and your screen name encrypted for some reason, and then decrypts it to put it on the page. So I can take the Remember Me cookie into the screen name cookie. The app will then decrypt it, and it'll display this as your screen name. So now I know what is inside the encrypted Remember Me cookie. Now I can change my screen name to that and let the app encrypt it into my screen name cookie, which will now be the right authentication cookie for the admin account. So this is the problem. This is why your cookie should just be a meaningless random number. It shouldn't be related in some way to something important like the username of the authenticated user, or, this can happen. I'd be able to predict the cookie that would make me someone else. So even though the encryption was unbreakable, I didn't have the key, I don't need it, because I'm able to use that system. And I've done this to get into PHP malware and everything else. This is always the easiest way to overcome encryption in malware, is to not figure it out very much, just find it and use their routine to encrypt and decrypt stuff. All right, so look for things that are encrypted and not hashed. One clue, for example, is if you log out and log in again, if it was really a random cookie, you get a new random cookie. But if it's one of these things that's really some encrypted form of your username, you'll always have the same cookie when you log out and log in again. That's a sign that they're doing it wrong. All right. So then password change functions are often very weak. An example of KPA, I don't know what KPA is. Oh, known plain text. I suppose you could look at it that way. Yeah, known plain text. That might be one way to describe it. Yeah, good. Although when you talk about a known plain text attack, you're usually talking about defeating the encryption. And here, we did not defeat the encryption. We just use it. Another famous example is the pass-to-hash attack on Windows. If you get control of a Windows machine, you can steal the stored password hashes, and you can then log in as those users over the network by just sending the hash over the network. So even though you can't crack the hash and you do not learn the password, you can still log in to a domain with the hash. So it's more of a, perhaps it could be better described as a replay attack. I get some encrypted stuff and I just replay it in another context, even though I cannot decrypt it. But yeah, anyway, so here's the next one. Password change is often the weak spot. You have a login, you have a logout, you have remember me, but when you change the password, it would logically ask you for username, existing password, new password, and confirm new password. That would be a reasonably secure way to do it. But the problem is administrators, of course, can change a password without knowing the old password. And that might be fine if the page that did that was only available to administrators who had logged in. But what they did was they used the same function for both of these, and all it did was check, and if there was no existing password in the request, it assumed you must be the administrator. So if you just remove that parameter, then it will assume you're the administrator, and this is, of course, not the right way to do it. Instead of really having a separate function that you can only get to when you're authenticated as the administrator, they just made two forms and then assumed you would be using only those forms. This is the fundamental problem in almost everything in this class. The developer assumes that you are using their form the way they wrote it, and they don't think that you might be using burp and sending in data that is modified from what the form creates. All right, so that's the game. Anyway, and this really happened to the AOL Enterprise Gateway application. All right, so as we played before, delete parameters and see what happens if you remove parameters entirely, and you may find that a missing parameter changes the function. All right, and here's another one I mentioned before in general terms. You put something in the shopping basket, you finalize the order, you enter payment information, and then you enter delivery agent. So if I can skip over some of the steps, then I can, for example, buy something, skip over payment, and go to delivery and get it without paying for it. And that's the attack, forced browsing. And as we mentioned many times, the right way to prevent this is that you should have a hidden parameter that's random on the page that you check on the next page, which will show that this person really came from here to there. And they did not go from 2 to 4. They must go to 3 and then 4. That's how you force people to do every step in order. If you don't, then you're vulnerable to this attack. All right. And that's the game. So try doing things out of order, do the same step twice and things like that, and see when you can find a logic flaw to exploit. Here's a fairly complicated one that's kind of cute. It was an insurance company, so you would submit basic information like your, can logic flaws be attributed to improper testing phase, SDLC? not testing all corner cases of the application. I think that's a fair statement. You really ought to be looking for logic flaws. But what usually happens, is that you just don't have people that have trusted enough minds working on the security team. That's why it's really not, it's not technical. It's just thinking of what could go wrong. But yeah, you could look at it as a failure of QA. Anyway, so first they give you basic information like what they're trying to ensure and how much money they make or something. Then it calculates the missing values. You give it all this detail about things like your health for life insurance and stuff. Then you submit an application, and that's sent to a human who reviews it to decide, how much to charge you and whether to sell you the insurance. And then this all is then sent back into the form. So the point is, you can purchase insurance at an arbitrary advice because you can go to the underwriter. The underwriter will then say, I don't approve, don't sell this person insurance. Then I can go back and replace the parameters to say the underwriter did approve it and change the premium because they stuck the underwriter into just the same flow of steps. And then I can log in to see what happened and I can modify the steps. And this is, again, like the previous one with the shopping cart. This is where data is sent to the user, and then that same data comes back to the next step in the server, and they trust it. And so I can modify the data, where now the data they're putting on my machine says the underwriter said no. I can just change it to the underwriter said yes. So they're bouncing, and this is from the developer just not understanding what's going on. They don't understand that the data is going to the user and back. Important data like that should just stay on the server and never be under control of the user. The only thing they should get from me is like my customer ID number so they know who I am. And information about the progress of my application and approval steps should not be going through my machine at all. But as we mentioned many times, many web apps do in fact bounce data off the user when they don't need to. So that's the game. Take parameters from one stage and add them to another stage, change things, see if you can change something that you really shouldn't be changing. And by the way, as we mentioned before, if you really used something like a signed ASP view state control with a cryptographic integrity control, then you could more or less get away with this. Then the user would not easily be able to modify anything. You could bounce it off the user and know that it hasn't been modified when it gets back to the server. All right, and so here's one where you register for online banking, and they actually mail you a piece of paper with your password to try to make it real secure, so make sure you're really a customer, and you have to wait a few days for that mail to get there and stuff. So they feel like this is all pretty secure. All right, and then the customer has to call in and authenticate. But the point is the customer information is stored in the database like this, with all the information about the user in a C customer object. And the problem is the same object is used for online banking and registration. So I can go online and register. Right, for number 4, type of this attack was used in a hacked device. Oh, in bank robbery. Oh, good. Glad to hear it. Probably somebody read this book and duplicated it. Yeah. Anyway, so now the problem is if you create an account and you haven't yet gone through that mail stuff to verify the account, it still creates this object on the server. And then when you validate the account, it just uses this object. So what you can do is you can sign up for a new account, and then you can change it. So you log in with valid credentials, then you go and submit a different customer's personal information in the registration function, and it will now overwrite the C customer object with a new object with a different person's name on it. And now you have managed to take your authentication and do a horizontal privilege escalation to transfer it into another user's account. So, and of course the problem here is you've used the same object for an early application and for an authenticated session later. And you ought to have something like different cookies for those two cases, where a newly registered person who has not yet proven who they are by getting the mail is given one kind of authentication token, and that token can never be mixed with another token for someone that's already logged in. All right. So that's the fundamental flaw here. All right. And then there's business limits. And so you can transfer funds from one account to another, and the application wants to limit how much you can transfer. So they'll have a statement like this: if the amount is less than the threshold, then it's okay. That doesn't require approval. If it's more than the threshold, it does require approval. So that's fine, except if you didn't think about negative numbers, you can just put in a big negative number, then the money will go the other way, and it will always be considered a small value. A similar one is where you have the wrong kind of variable type used, so it really has a maximum value, and you can just use a really large number, which is interpreted by the computer as a small number, that sort of thing. All right, so if you're going to have numeric limits, then you have to consider this. Make sure that you can't take negative values or ridiculously high or ridiculously low values. All right, and many people try to limit the amount of things you buy, the size of a transaction, and so on. And similarly is cheating on bulk discounts. So you get, say, a discount for buying several products altogether, but the way they wrote it is when you add them to your shopping basket, by the time you add like the third item to your shopping basket, it gives you the discount, but then you can just remove some of them from the basket before you buy it, and it doesn't turn off the discount. This one happens over and over and over. I remember, must be 15 years ago, they said Microsoft is giving out a USB drive, and you can just get as many as you want by filling out this form over and over and over. And I tried it, and by then they just turned it off because everybody started doing that. The same thing happens with online surveys. Like they tried to determine the Time Man of the Year with like an online survey, and so some people just wrote scripts and voted a million times and made someone ridiculous the Man of the Year and such. This is why we don't have online voting in America. It's very easy to go through something like Tor, so you appear to be a different person and vote many times and so on. Anyway, all right. And then there's escaping. So these guys have website, and they're trying to block script injection. So they add a backslash for all these special characters, and the backslash means it will not be interpreted as a meta character. So that sounds fine, but the problem is they forgot to escape a backslash itself. So if I actually put in a backslash, then the application will put a backslash in front of the semicolon, but it won't put another backslash in front of the backslash. So now the backslash applies to the backslash and not to the semicolon. So this will allow me to sneak a semicolon through. I can sneak any of those forbidden characters through this way. So this is why it says many times in the book, whitelisting is better than blacklisting. Instead of somehow listing all the dangerous characters and trying to remove them all, you'd be much better off to just list all the good characters and only accept them and nothing else. That would be much safer. It's much harder to fool that. All right, here's another one. So again, I'm going to try to remove a bad character. With this modification, I'll put another quote in to double all the quotes. But I also have a maximum length limit. So obviously, if I input data that is too long, I can defeat it. So here's the common injection, admin apostrophe dash dash. So I'm trying to make it be username equals admin and then have a comment character to end the rest of the line. But because it adds a second apostrophe, that doesn't work. And so this line will not be a successful bypass. This looks like it'll just be a syntax error. So what I do is put in 127 A's and then a single quotation mark. It then adds another quotation mark, but the length limit removes it. So now I've got a syntax error, and now I just have to write it more carefully. So I put in the same username and then the password of this, and that way it will again let me in. So it's a little inconvenient, but the point is you can bypass the doubling of apostrophes. So if you want to detect this, you can try strings like that. All right, and look for syntax errors and so on. SQL syntax errors are what you usually look for that sort of thing. And then there's a search function. I think we talked about ones like this quite a bit. If you have a bunch of things people are supposed to be paying for, but you don't bother to actually limit permissions, then you just have insecure direct object access. All the things are actually just sitting there where anybody can find them. The only thing you're going to do is only let people find them if they paid, but there is a search engine, right? So you can search to see if there's a article on your topic of interest, and then they'll try to charge you money to see it. But you can perform this aggregation attack where you deduce data from the results of the search. So Since it searches the full text, all you have to do is guess at the contents, and the search engine will leak out the data. So if I think I look for consulting, okay, there are some consulting articles. Then I look for this press release, no matches. I was able to deduce this name. Then I look for merger, share issue, dividend, takeover. There is something about a takeover. So now I guess what the takeover is, and when I get it, I'll find a match. So, just like blind SQL injection, you can get some information out of the article that you don't have access to because the search engine has access to it. They call that an inference attack. All right, and so they've done this to like brute force a password out because there was a password in there and so on. All right, and then debug messages. Error messages often have too much information. There were quite a few injection attacks in this class where we were able to get a secret to appear in an error message. So here's a new buggy app that puts out error messages showing tokens and user's identity, and the idea is that you would only see errors associated with your session. So it wouldn't compromise somebody else, but the problem is they put it in a shared session container, like in a temp folder, which is also used by other people. So sometimes you will see other people's error messages. This is a race condition. This is the most common type of race condition, where you put something in the temp folder and then you go back and retrieve it later and hope it's still the same. But since you're a multi-threaded application servicing many users at the same time, another instance of your application might be changing it in the meantime. This is so common that we were just doing this yesterday with someone working on Debian. Nowadays, every application makes its own separate subfolder of the temp folder so that the objects it stores are not easily found by another process, just to prevent this, because it happens all the time that people just put things in a temp folder and forget that that creates these race conditions. All right, so this means one thing is you could just wait until two people use it at once and you'll get their cookie, but what's even worse is you could just pull the error container over and over and see what's in there. And the container in the temp folder will just keep having everybody's error messages, and on you go. And if you don't find enough errors giving you enough cookies, what you can do is you can send people instant messages or emails with a link to click on, which will cause an error, like a syntax error. Now, putting an apostrophe in a URL will typically do it. Then when they click on that, it will create an error, including their session token. So, there's lots of ways to get session tokens from people. And here's another similar one. So the authentication has been highly secure, multi-factor, and all that jazz, but they notice that sometimes people log in and they see somebody else's stuff and they don't understand why. It happens sometimes when two users log in at precisely the same time, so it's the same old issue. It stored something about you in a shared session variable, like a temp folder, and it was read back an instant later. That's a race condition. You store it, then you read it back. If it changes in that time, you'll see somebody else's stuff. These kind of things often slip by because people write an application and they test it with only a few users, and then when they actually deploy it to their customers, then it has thousands of users per second, and these problems appear that will not show up in prototype testing. Anyway, so that's the problem here, race condition. And all right, so to prevent this, you just have to document what you're doing and have a reviewer that says, where did you store stuff, where did you get it, and make sure that you're not storing it in some kind of shared object that's also shared by a separate session. And they have to understand that multi-threaded applications are running multiple instances in memory of the same thing at the same time, running from the same code. All right, so you have to document the purpose of these components and so on. I was doing a bit of this for Amazon. A couple of years ago, I started looking in burp at all the cookies in the Amazon website. I found some of them had your username in plain text, and I found that some of them are transmitted over HTTP. And I thought I'd found serious vulnerabilities in Amazon. But when I analyzed it, I realized they really had done this. There's like 20 cookies when you use an Amazon site, and some of them are just to target ads, and they're sent in securely, and they don't matter. But the ones that actually have to do with buying a product are transmitted securely. And so they have multiple levels of meaning for the cookie and different security levels for each cookie. It would be so much simpler to just make it all HTTPS like Google. But since they have ad partners and custom and stores connecting to Amazon as third parties to sell products and stuff, they can't expect all their business partners to upgrade to HTTPS, so they really have a complicated mess where part of it is secure and part of it is not secure. But as far as I can tell, they did implement it correctly, where the part that was not secure could not really be used to do anything important like buy a product. I tried a bit. And so that's what you do. You have to document everything in such a complicated case and then review it to make sure that all the important stuff is correctly secured. Quite a burden, but of course worth it in a big company like Amazon. And you got to do a security review imagining everything that's stored and what it means, and so you have to have clear documentation. And it appeared to me that Amazon had really done this. All right, so you got to think about the ways it handles unexpected behavior and the side effects of the interoperation between the components. All right.